So let's welcome Dr. Ma to give his presentation. Dr. Ma, please take it over and start your talk, please.
Thank you. Thank you, Dr. Fang. And it's my great pleasure to be the speaker today. And I acknowledge CNKI for providing the platform, as well as Alberta AI for giving this opportunity, especially Dr. Fang and Mr. Liu for today's event. Welcome. What I'm going to present today is talk about artificial intelligence challenges, applications in engineering informatics. If we look at the engineering informatics as an application domain, let me start the presentation. It is a field of application covering all the information systems for engineering purpose. It has been established for the past 30 years also. Well, artificial intelligence is a technology evolving very fast and has become the main driving force for innovation in many, many areas. And today we see the economy is driven by new technologies, and artificial intelligence play a very important role. So I would acknowledge that AI is a transitional driving force and upgrading the traditional economics and engineering for product and process engineering. And here I specifically mention that product and process are two streams of technologies, and then AI is upgrading all these technologies. So it is so important to acknowledge all the changes here. Traditionally, we know that for product and process engineering, it involved the disciplines of industrial design, optimization, and those probably in the field knows about the lean manufacturing. However, network-based artificial intelligence applications, especially applied in real time, is the new field of engineering informatics. We see the opportunities. So artificial intelligence enable concurrent and collaborative engineering, and it also evolved into engineering management. And if we look at the modern economics, and if you look at the current pandemic vaccine rolling out exercise, we would appreciate that behind such kind of economics, there is a huge domain related to collaborations across the global operations. So we see that network-oriented operation and control need a lot of attention in the background of economy. So we talk about artificial intelligence, also talk about its future, its trend. So we all know that there are huge amount of algorithms developed with the AI technology. For example, we know the Deep Blue, and we know the world famous chess computation man and the computer. And we found that the computer can not only learn the patterns, but also can generate solutions. That is a great achievement. We acknowledge that in the world, Alberta University and also Edmonton community has been active in these areas. But when we look at the artificial intelligence in the engineering domain, we are moving forward to network-oriented, smart and autonomous operations. We name it as EAI. And across the globe, we see the best practices in traditional engineering excellence. And we talk about multiple concurrent work, such as, say, talk about the basic engineering, more traditional, but also talk about the decision support. And we look into what is the best for processes. So we involve a lot of industrial practices, involve optimization. And we design the best with new energy evolvement, like to address the climate change. And we look into a lot more than single discipline. So we see that interdisciplinary and cross-disciplinary work is becoming more and more common. And we address network collaboration and with new demand with AI as the strong force. And we define engineering informatics again as a major domain of application. If we look at the picture of a typical product, and you see that the engineering work behind it represents the best quality and serving the purpose, and all this single product has already been the result of collaboration, and the company collaborate for survival. However, new challenge is coming. If you look at the modern manufacturing technology, new methods such as 3D printing or additive manufacturing method is changing the traditional way of manufacturing. And collaboration between the robots and automation with artificial intelligence has been so demanding, so popular, and behind it involves so many new inventions. That really gives us an eye-opening effect. This is a recent development with a company, and the 3D printing industry featured this application with multiple robots to do the 3D printing. We see that it involves a lot of smart algorithms, data, and optimization of the efficiency with high reliability and scalability. That is new. That is not only depend on automation with a single robot, but with multiple robots. It is dynamically collaborating for a piece art, and we see intelligence level has been enhanced. And recently, probably we have seen those kind of videos that Boston Dynamics published. Those robots can talk to each other, dance with each other, and they can produce a really great dynamic performance, jumping like athletes. So what are the trends? And we see the new domain is not a single device with artificial intelligence. It's not talk about the single applications. We talk about an evolving paradigm of network-centric artificial intelligence. And if we recall what is the history over the last several decades, every decade, there is a generation of technology, and we started with the mainframe, and then worked after 10 years, we have the mini computers, and then one more year, we have microcomputer and a personal computer, and another 10 years, we have the server client structure, and now we look forward to the wave of collaborative artificial intelligence. And we look at the domains. Actually, here I show a few domains. It's more than just to say software engineering like a cognitive domain. I think in the past we emphasized a lot, for example, cognition of semantics, such as language understanding and listening, and also these days signal processing, sensoring, and so on. That all involve some kind of a recognition of patterns. That is the core part for AI. But now the application domain is going beyond this area. And for example, we want artificial intelligence to play the role to serve purpose for engineering domain, especially in the physical domain, in the physical world, in the manufacturing processes. So the background has changed. And we also look into the areas such as network-centric warfare. I think most of the countries, they are actively developing their programs. Well, other than the military use, I think we also look into how we can share the intelligence over the network. And we are creeping into the social domain. I think most of us using platforms of different kinds with group technologies. I think we are in one of those social media groups or several. And with such kind of sharing culture, and we have a lot of concerns, right? And we all also want to compete with the tools we can master. So that again emphasizes the artificial intelligence within the control, within the management of human beings. And artificial intelligence should leverage intelligence resources globally. And one of such kind of concepts is that nowadays, network is the computer. And we should be able to access anywhere for all the resources, including high-end artificial intelligence resources. And what we see that global infrastructure is catching up. The high-speed internet enable us to really solving the problem, and with the complexity, we are talking about millions and millions of nodes for all the problems. We talk about the fine-grained. This is a terminology I think fine-grained AI agent to solve the problem of all shapes, all sizes. And here I have a quick example that IBM and Bank of America, they have the advanced IBM cloud for financial services and covering the whole life cycle of the transactions. And you can see the videos introduced on the YouTube channel. And we have observed the critical moment, unusual moment of our modern society facing the challenge of pandemics. And we see that networking with the computer is so important. It's really having the education, health, care, and the economy running with the maximum leverage of network. Data centers are thrived. And we see that is the power of network. And then we look into what AI could change. We look into the trend that it will be a pervasive, internet-based, universal client front end. It will be unified, generically accessible by all the applications through a common gateway. And we see that the technology behind it will be autonomous agents for artificial intelligence. And we see that in the past, we have developed Fortran language. We run programming in a procedural way. And Fortran 77 has been the main driving force for many computational applications. And then we recall that we have the C software, C program language, and we were able to access devices, and not only for the high power computation. And then we have the C++. That was the first generation language that was able to have declarative programming. We started to have the concept of object-oriented programming. We have the classes, we have the instances. We can do the polymorphism. Now, we are talking about high-level artificial intelligence language like the Python, and we look into the active agents to be circulated on network. And here we talk about the hardware, the bandwidth of the speed, and we have already reached to the stage that 5G and 6G wireless network, and we know that optic fiber is changing the speed every year, every month almost. And this is an example AT&T fiber can provide. All right. With such kind of a speed, many things could happen that in previous situation we never imagined, such as a video streaming, multi-channel video streaming. And if that can be done, you can imagine artificial intelligence agents could serve the purpose to run their functions easily. So in the past, the bottleneck of network speed has been eliminated. So with this kind of a new change, even in the developing countries, we are seeing that the internet is becoming the town square for global village of tomorrow by Bill Gates. And we see that, imagine a scenario that in third world country locations, they can already gain the artificial intelligence access through public institutions. And what happened for the second world countries? They should be able to afford the services from the artificial intelligence resources. And for the first world country like US, and you can see that very soon the access to artificial intelligence is ubiquitous and like a telephone. Everybody are using artificial intelligence one way or another. I think one of the growing countries having the advanced active AI rolling out, that is China. So is India. And when we talk about this, then we start to think about the pandemic, everybody is self-isolating in-house and close doors and trying to work out, find fun, and keep healthy. But now, actually, one industry is booming. It's network-based virtual commerce. And we are talking about the rules played with active contribution, artificial intelligence. Did you realize that you have been categorized with what you like and dislike? Did you realize that you have been sensed with the locations? Did you realize that actually you are using a lot of VPNs to access your corporate data? Yes. Eventually, internet-based artificial intelligence commerce, not just the engineering, the commerce, on the B2B level and B2C level will be business as usual, will be the norm. And then we see it's no longer a high-profile event that there is a competition between human being and the machine, and the Deep Blue will be able to win human brains and with the game, and then that is a big news. I tell you, now it's commonality. So with that, let's look at one of the driving force for economy, manufacturing. And manufacturing is a truly network-based industry. And it is depending on the world-class coordination and management of engineering systems. And behind it, software is essential. I would say these days the importance is more than 50%. So we believe that the AI is filling more niches of solutions, and the solution for the industry informatics throughout its life cycle, we call the ecosystems. Imagine that nowadays the aircraft industry, and the picture shows how they control the robot doing the the clapping of the fuselage of the major airliner, Boeing 777. And you probably also see below that the cell phone has been assembled in China and with the license of their IP. And we see that artificial intelligence gives you not only the money, it gives the certification to run your company. It gives you the IP access to instruct the machine to run. And other than that, I think we know that artificial intelligence will serve to meet explicit and implicit individual needs. Your data backup, and more than your needs. In fact, they are getting your information. There are many parties are collecting huge amount of data without your notification and then used for their purpose. Hopefully they are under the legal framework, but might or might not be so. So we see that artificial intelligence will drive the industry. And what is the new phenomenon? We see the quality has been changed. Artificial intelligence enables optimal ways to develop and produce product. And with small customized lots, and that is happening. We're also observing that the artificial intelligence is driving the industry to more creative energies. And so that the team can work together, so that multiple partners collaborate by making use of each other's strengths, and they can result in the niches. And that is interesting. Niches means the small and fine-grained and functionality that enable divergence. Not old days, we are changing a lot. Now, one of the examples I'm trying to probably give you a picture is how scalable of artificial intelligence is. I want to mention one of the company is the Siemens from Europe. And they have a product they call it MindSphere. MindSphere. And this product is a collection for all the solutions for most of the engineering and processing industry. And take example, this artificial intelligence tool enable the virtual engineering design and operation for the whole refinery, covering the whole life cycle. And you can imagine the scalability and interoperability across the modules, stages of different kind of teams and different part of the life cycle. Machine learning in robotics is also revolutionized. And in the old days, when you have the robot, you just had to teach the robot how to move. You never know whether it's safe or not. You never have the accuracy control. You probably can do a little bit, but you need a lot of programming and in order to enable such kind of accurate control or better performance. And now that barrier is more or less gone. Machine learning take the place, and the machine can learn what is best work for its performance. And you can see also the new generation of robot can work hand in hand with human beings. That's what we call the collaborative robot. And beyond that, information are downloaded to the site, and operators should be able to see the physics, controlling parameters, adjustment possibilities, optimize the local performance. And not only that, we also see that there is more opportunity for group dynamics, teamwork than before. And perhaps we never imagined that before the pandemic, we could have the whole class teaching 200 plus students over the internet without seeing each other, without utilizing the lecture hall. That is happening now. And we also see there is some unchanged phenomena that group dynamics will never change. Teamwork will be there. And people leverage the technology to overcome the constraint and serve the purpose to gather energy together, synergize for the purpose. That is why there is a new field called Engineering and Computing, new program. And within the engineering management domain, we need a new generation of engineers are able to best use artificial intelligence, serve the engineering community. I'm highlighting the trend that every day when I received new papers from different submissions, I was shocked with their discoveries, with their developed algorithms and the fanciful capabilities. The world evolving so fast, and that is giving the momentum. And in each era of the history, there is a main driver, and AI is the main driver now in technology. And sometimes we see that AI applied to community is the new demand. Think about it. I want to use artificial intelligence results from the fingertips. I want to have the transparency for my authorization, accessing to the complicated corporation data. I want to collaborate with large teams on site and constructing the high-level buildings. For those people might be in my age group, they have seen such kind of collaboration conferences. And those time we realize that we can broadcast getting people on the conference, and then we can see their images. We could discuss about the problems with shared vision and so on. But we still depend on the people together. We have to sit close in the meeting room. Now, with artificial intelligence, this has been over. Very few people travel across the globe just for a video conference. Artificial intelligence infiltration into the engineering plus management, we will face tailored multiple views. In engineering. Instead of having the multiple pictures, actually we are seeing customized views for individuals. If you are an assembly engineer, you will see relevant information as needed only. Artificial intelligence will create a lot of cooperation opportunities across the globe, and this is the top niche in modern engineering. For those younger kids who have graduated with the skill of both engineering and computer science, for those people looking for the increment of salaries, if you are good in artificial intelligence as well as engineering management, I think you have great leadership potential. So what do we see these days? We see the traditional concurrent engineering has been evolved into AI engineering. It's a new journey. And if you recall that at a certain time, about 30 years ago, concurrent engineering started from Japanese companies, eventually evolved and becomes the trend in the world, and then North America followed. And in the 1990s, now I think the whole world is on the equal foot, and then they have to look into digital enterprise. It's already reality. And we are looking into artificial intelligence to find the ways through factory halls and optimize all their power consumptions, driving the live operations, machine performing with quality control checks, and localized AI applications offer tremendous potential for economics, for the industry. The production will be more efficient, more flexible, more reliable. And we see we are having less and less windows for those startup companies, and we are having more competition in the market. All right, so with this, let's look at what is the effect of AI engineering can do. That is a new term I probably invented today. And we make use of AI tools, AI resources, AI algorithms, AI data structures that enables intelligent autonomously configuration systems. Means we will configure AI system for real use, for the niche applications. Right? For example, we want to seamlessly embed AI agent into product and process development environment. I got to go faster, okay? And then we look into the customer expectation and then individually satisfy customer requirement. And we virtually have the clusters and then support cooperation, trust, and sharing. And we will have high quality decision making because we have a large amount of data to support. And then you will have the parallel working thread to support the whole life cycle. And you will be able to synchronize and make the comparison based on data and exchange to have the consensus. Optimization is no longer I would say high-end engineering solution. It's just a common sense. And if you look at the product lifecycle management system and how artificial intelligence could play in different fields, different kind of aspects, I would say artificial intelligence will be like an agent and will be actively applied to individual areas. You can name it, any of them. We call it penetration. So the statement here is that artificial intelligence engineering revolutionized the traditional self-contained integrated systems and will have the plug and play capability for interoperability within different systems. And that will change the engineering world tremendously. If I quickly look into CAD, artificial intelligence will be optimized topology. Later I give you an example maybe. And manufacturing process will be optimized based on artificial intelligence to consider material, surface requirement, and also the best efficiency for producing part. And everything is changing in that way. And let's look at a little bit of management. We see in engineering management, which is traditionally we call the industrial engineering. And we have learned a lot of optimization. We learned about lean manufacturing. And now we see all this can be automated by artificial intelligence. Leave the job to the best people. Leave it to the machines to do the algorithm calculations, to optimize the 3D calculation, space and position control, force control. And we see artificial intelligence and control technology will be get married and increase the reliability and the quality of manufacturing. So here is a statement. Artificial intelligence on the factory floor. The AI will breathe new life into factory shop floors. That is a very interesting word by Frost and Sullivan. If you look at the technology development trajectory, and we see over the years, different generations of technology played roles. And I here especially mention that the Industry 4.0 developed in Europe, that was started 2013. Started from 2014 to 2015, we have a plan championed by Chinese manufacturing sector called Manufacturing 2025. And we look forward by 2035, AI collaboration will be the day-to-day reality in industry. And that will be a huge opportunity. Just think about one of the reporter, that is Roland Berger, and he mentioned that within the near future, $420 billion opportunity for West Europe alone. And in the world, we are talking about $15.7 trillion business globally by 2030. And a lot of old day terminology, such as CAD/CAM integration, such as SIMS, computer integrated manufacturing, has been replaced with new terminologies under the Industry 4.0. And for example, digital twin becomes very important to understand the mapping between the virtual world and the real world. And then we have seen AI will play a major role to realize such kind of mapping, synchronization. And we call it integrated edge to cloud and partner within the ecosystem, closed loop digital twin, and IoT as a common support for infrastructure. And do you recall what I mentioned about what essential element for AI in engineering? It talk about the control technology plus AI to have engineering in real time. That is the characteristics for the future. And quickly give you some example that I have carried out some work with my current PhD work, and we use the software model to accurately predict the complex phenomena. And perhaps for those in the working industry, you know that this is thermal spray, and then you can see that it involves the high temperature and high velocity particle process to improve the hardness of the surface. And this phenomena we can modulate accurately with the trend, with the quality control, with the model in safety, and we have being able to reflect the true reality with virtual models. And we developed the control strategy to optimize the performance throughout the different devices, such as the gun, the spray, the flow of the hot air, as well as the surface. That is one of the work my PhD student and myself did. And if you recall that I did mention about a company called Siemens, which is a big innovation company in Europe, and it developed a kind of technology that enable a single unified system to support multiple applications from electrical design, piping, HVAC, to industrial design like cars, shipbuilding, everything. And the collaboration happening is scary. It's not because they are enable 3D visualization, not just enabling, like a customization for different kind of design. They are involved AI. So we develop a new concept called artificial intelligence enabled collaborative product production development, ASEE. Well, there is probably a picture that gives you a new experience that you will be having a car fully automatically driven with AI control algorithms. And you will be in a virtual world and touring with this self-driving car. Actually, self-driving means the autonomous car. And you will have the full experience of augmented VR guidance. And you don't need to read the map. Your map will be loaded to you. And you don't need to plan the path or the road, and they will guide you to the destination. And automated control plus artificial intelligence. So for business, be prepared for the new wave of technology and competing on the level of collaboration with intelligence. customer focused, more flexibility, more agility, and manage the risk. And this is the picture showing that AI collaboration, people, infrastructure, and policies will be lubricated all with artificial intelligence to have accurate understanding about the scenarios. And I just quickly give you some example here. I know that my time is running up. I will probably take another 5 minutes. One example is that my student and my colleague, Professor Lin Les wrote, and we worked on the industry risk model for the oil and gas industry with a database from different kind of accidents, 54,000 incidents report. We can work out the patterns and make prediction of the possible highly popular types of accident and scales, risk levels. And we will put all these kind of report in a huge database and enable company to take measure beforehand, work out the strategy based on time of the year, based on the type of operation, based on the indications from the devices. That is another application. I know that time is rushing. You wouldn't be able to appreciate the details. I have worked with my student to develop a human resource system, and we will monitor actually the usage of computer over the network, see the pattern of the productivity, and benchmark with their common patterns and look at the performance of individual people. And we have what they call the next generation workers and how they digitize their work, and we can benchmark with their efficiency, performance, and bonuses, for example, and give them the right kind of justification of different opportunities. So with this, I also probably have a lot more to introduce, but I quickly skip some of the slides. And for example, we introduced the concept called virtual AI-enabled manufacturing enterprise. This is more like a open society kind of enterprise. You have to be able to have the core organization and open with the partners, have the AI resources, and then in this case, AI will be paid as resources, as a service, right? And then you have the layers of network supporting different kind of department functions and so on. So virtually, the whole enterprise could be virtual, assembled based on the opportunities. And we also see that the teamwork with the multiple views, like what I said, customize the multi-view effect, and human beings will be assisted with a huge amount of data and will be able to see both the virtual world and the physical world. And you see the control parameters, design purpose, optimization phenomena, ranges of performance, and so on. So I skipped this one. This is talk about the different areas covered by AI. And we have to mention one thing in Industrial 4.0 framework, that is cyber physics system. The essence of this is that in the real time, the virtual world model should be 100% aware of the physical world, what is happening, based on the sensor and technology and the virtual models. All right? And we also see that there are many traditional domains like a process in manufacturing, like a plastic molding. And in the old days, you didn't know what's going on based on a lot of times on experience. Now, we digitize it with accurate finite element analysis. We simulate the hotspot. We solve the problems. We improve the quality. Again, this is a work done by my PhD student and myself. And we see the future cyber physics system will incorporate AI and machine learning. AI and machine learning actually is the same thing, right? And they will be penetrated through powerful finite element analysis and CFD, computational fluid dynamics. Engineering domain will be supported with powerful AI algorithms, and they will really solve the problem of uncertainty because you can predict the phenomena. That is the beauty of CPS. And I would just show one slide now is talk about the 3D material innovation. And we based on computational power to work out the non-homogeneous materials supporting the purpose of loading with varying geometries. You can see the micro geometry change with this part, and this is the 3D printing part, and the optimization with such kind of non-uniform gradient-based material. We will be able to customize the material design based on the loading situation. And now you know that 3D printing is installed even in the submarine. When you go out of the seas, you can design the parts and do the repairment on site. More than those, we can also customize the oil production in Alberta. And you know, probably SAGD is a phenomenon produced oil in oil sands operations. And we use artificial intelligence, advanced safety modeling, and simulate the thermal effect, the flow effect, and the design device modernization. And we can really predict the hot air's cooling effect and also the production of the oil. So the general trend is that human beings still will be part of the future technology map and integrated with the cyber physics system and supported with AI. We will be able to control the world in a much more autonomous way. And for example, I think you know that human beings will use a neural system to support robots and control robots. Isn't it a dream in the old days, only happening in movies? So with that, I think we will use AI for repairment of complicated, say, industry like a rocket, like missiles, like very complicated aircraft industry, and so on. We will be able to integrate things together. So with this, I summarize and add today's presentation. I would say AI infiltration in engineering informatics will change the scenario and have a new generation technology supporting within and beyond the market and support the intelligence service everywhere. I managed to rush through all the slides, but I hope that we can still have time to entertain questions for about 10 minutes. Dr. Fang?
Okay. Thank you very much, Dr. Ma. It's a very interesting topic, and I think everyone see a very big picture about engineering in the future. So even 40 minutes is not very enough. So there are
a long time, eh?
Yes, it's really a lot of information we need to digest. So there are more questions coming. Even I have my own question, but we have to, make the audience ask first. So there is the first question. There is no doubt that AI has so many advantages in multiple aspects. But regarding education area, people can only be educated by people, not by machines. So my question is, should we have a balance in the education area between AI assistance and the teacher's teaching process, and how to make it?
Right. I fully agree that in education industry, I call it industry, is that it's a human engineering project, and lecturers, professors need to convey the knowledge to another human being, and there are multiple ways to do so. And there is one aspect that never be replaced by algorithm, software, or hardware, is the human touch, physically, emotionally, and intelligently. However, we also see the technology evolves to support other aspects of the education. For example, virtual labs, right? And mathematical solutions, optimizations for design concepts, and the visualization as well. And we see if we have the same task to teach students with AI support, I can better visualize, better illustrate the design space and options than before. But on the other hand, as I said, we will never replace human communications because that is part of the sense of belongings, sense of participation, and moral support to each other. We are still belongs to society, aren't we?
Yeah, sure. We're still human beings.
Right. Thank you.
So, yeah, thank you for answering this question. So let's go to the next question.
Yep.
So, do you think AI will be the key to proper IoT, Internet of Things, security? Why or why not?
That's a very good question. But I personally, again, personal opinion. There are many people working on the IoT areas, and many of them actually with the AI algorithms. And algorithms have been able to processing data, graphics, and also the sensing information like discover the faults and do the reasoning behind the invisible kind of signals. And AI has been playing a lot of roles in IoT field. And I would say both are in a parallel way. But I still think that AI and IoT are two parallel technology. If you look at the potential, say, classification in the discipline. But now I still think that by the end of the day, we need different niche applications to tailor such applications based on the fit. We call it niche areas. And certain things will be better off with IoT technology because you are sensing things quickly. But AI has a higher level for decision making, for judgment, for identification of issues. And if that is the case, I would say there is a kind of a blurring or transferring of the application from one level to another. In general, AI is still a higher level and kind of a algorithm than the IoT. But the IoT, as I said, is a foundation for a lot of information. I would say, let's think about it. They are different levels. They are different parallel kind of technologies, but they are infiltrate each other. They are becoming more like getting involved by making full use of each other's advantages.
Okay, yeah. So I think everybody is very positive about AI nowadays. It seems it's on the top of all levels. I'm curious in the future whether there will be, other kind of technology over AI.
Well, I'm not sure. To be honest, I think AI has been a very broad definition covering a lot of aspects. And maybe if you think characterize AI, and there is called intelligence and there is artificial there. So if you philosophically think about anything created artificially and has the intelligence that is classified under the umbrella of AI, is there any new technology that is not artificial or more intelligent than human beings? I think the question has to be answered philosophically rather than technically.
Right, that's a kind of philosophy question.
Yes, I think we always have new technology coming up, but any technology not artificial, I'm not sure. So the answer is unknown. There are always some known unknowns. There are some unknown unknowns. You recall what I'm saying?
Yeah, interesting. Yes. All right. Okay.
The former U.S. Defense Secretary Rumsfeld talked about the Iraq War. You know,
Iraq
there are always some known unknowns. There are some unknown unknowns. Who knows?
Yeah, who knows?
Yeah.
Maybe. And yeah, there is the third question. AI. He's asking, AI is predicted to restructure the job market, especially in engineering industry. I don't think it's especially engineering industry everywhere. So what the education system can do to tackle with this situation?
I think like many other technology already done, AI penetrating through education, and the future job market demand basic AI skills knowledge for every worker. I mean, the professional workers. So I would say that in the near future, from younger kids all the way to the grad student level, certain knowledge about AI application can choose, like network, right? Like any kind of software application, Windows and so on. All this becomes a demand for the core skill set for any future workers. So I personally feel it's natural evolvement, like we have to have the second language in my time, or we have to be able to do a little bit of kind of fortune programming. I think in the future, yes, for job places, any engineering field, engineers need to know AI, typical applications, typical controls, and expected outcomes from them. So I see, yes, AI changing the landscape of job market.
Is it a disaster or is it a opportunity?
I think it's
for human beings.
Those not able to grasp the essence of AI might be a disaster. But for most of the people, I'm positive to say that it's more opportunity for those, especially younger generation, to evolve the economy. I personally believe it's going to be a huge opportunity for younger generation.
Okay. All right. So time is up. Please allow me ask the last question.
Sure.
So we are talking about AI in every industry field. So regarding the engineering industry, let me see, is there any new question? Okay, regarding the engineering industry, could you tell us what is the challenge about AI in the future contribute to this industry? The biggest challenge.
The key word, I will give you one word only: interoperability. And this is more like old days when you were able to do the C programming or any kind of programming, any kind of software engineering work. If you can do a piece of good work, that's easy. If you can do a work workable for all the applications, that is not easy. And it's a huge barrier. And a good piece of software engineering work, like artificial intelligence, to be supporting engineering field with broad opportunity for different projects, different kind of disciplines, you need interoperability. You need generic solutions and with robust data structures. And for those people working in software industry, they would appreciate that eventually interoperability demand the standardization of protocols, demand the standardization of data interfaces, and finally, you need the protocol for service. So I believe that will be the next level of, I would say, industry involvement. To enable AI, not only for one particular application, but for many different applications, and also network connection to access. Hopefully the company will not stopping by the excuse of copyright or whatever. Access is everybody's right.
Okay.
I tried my best to answer this question. I believe there are many different versions of the questions from the floor, from the audience.
Right. It's not, I think it's, yeah, in summary, in the future, it's not just a piece function. It's you know, there's many areas, they dynamically interchangeable, you know, among the, you know, each domain. So
that's why the collaborative AI, and we see the AI will be self-defining, becomes agents. All these agents will be serving the purpose, and they will be competing for marketplaces. They will compete for their performance, and eventually still is the driving factor that providing the support for the service. So service is the leader.
Service the leader.
Yeah.
Yeah, that's great comments. All right. Okay. Thank you, Dr. Ma, very much. I think the lecture is already, you know,
I'm grateful to have this opportunity supported by Dr. Fang and CNKI, as well as Alberta AI, to have this opportunity to share my view.
Okay, yeah, you are very welcome, Dr. Ma. If you have any professors, they have, you know, topics interesting want to share with us, they are very welcome to contact us or contact you, you know, when we come to this platform.
If I have some idea, I will let you know, but I have to say that you have done great work. I look at the past video recordings and other seminars. Those colleagues are well recognizable and reputable in my field. I admire that their great work as well as the future service. I believe you will have a lot to come.
Thank you. Thank you very much for your comments.
Have a good evening.
So, all right. So the audience in front of the, you know, the screen, the time is over. So we encouraged you, if you have any questions to ask more, then you're welcome to contact Dr. Ma directly.
Yeah,
he already put the email address here.
Yeah, I welcome anyone contact me for specific questions related.
Okay, yeah. So yeah, you can also contact us, Alberta AI or CNKI China. So today's webinar will be over. So thank you very much, Dr. Ma, again for today's impressive presentation. And thank you everyone who attended the meeting. So time to say goodbye. We will see you next month.